All right, we are live. Hello and welcome everyone to our webinar today. We are going to wait just 30 more seconds, let our final friends trickle in, and then we'll get started in just a moment. Before we get started, I want to make one quick announcement, a little bit of a shameless plug. Here at the maintenance community, we are having a big special event this week. It is the Career Development Fair coming up tomorrow, Wednesday, and Thursday of this week. We have a ton of events, live and virtual events that you can join at the hour, or giveaways that you can participate in no matter where you are located in the world. So we will be sure to share the registration link to that event in the chat here. It is 100% free, so hoping to see some of you all there. That will take us to our webinar today. So hello and welcome to our webinar. I am Heather Grant, one of the community admins here with the Maintenance Community by Upkeep. If you are not already a member of the Maintenance Community Slack, we would love to have you join us. We will also send that link through in the chat along with the event link for this week. For our webinar today, I have here Ricky Smith joining me. Ricky is our maintenance expert in residence. So that means he puts on one webinar just like this every week for all of our members. Thank you, Ricky, for being here.
Thank you.
The recording from our session today and all of the slides you see here will be available in the Slack tomorrow. Ricky is also available in the Slack to answer any questions live. So if there's anyone you know who would benefit from hearing more of Ricky's expertise, please feel free to send them the replay of the webinar or the invitation to Slack itself. Final piece of housekeeping before we get started, you'll notice that your cameras and microphones are not turned on today. So what you'll do if you want to ask a question of Ricky or answer any questions that Ricky asks of you, you'll use the chat feature on the right-hand side of your screen there. Feel free to chat your questions if you're having any technical issues or anything like that, and we'll work to get those resolved. I believe our presentation today will be a little bit on the shorter side, so that means we'll have plenty of time for questions at the end. So please feel free to ask anything along the way, and we will have plenty of time after Ricky is done with his slides to answer them. That is all from me. Thank you so much, everyone, for joining, and Ricky, I'll hand it over to you.
All right, thank you. Welcome, everyone. I hope you enjoyed this session. It's one that's near and dear to my heart because most companies don't have repeatable, effective corrective maintenance and preventive maintenance procedures. So we're going to talk about it. So why companies do not use preventive maintenance and corrective maintenance procedures? I mean, they may have a procedure, but not effective, Well, organizations have never seen what an effective procedure looks like and the value of it. I mean, what is the value of it? The value is of a procedure that's repeatable and it's also has specifications, has step-by-steps in it, is that no matter who it is, it could be your best maintenance technician or your lowest level in knowledge, the procedure brings everybody to the same focus. So other reason why they don't lack of knowledge in preventive and corrective maintenance best practices, like I've got over to the right, preventive maintenance should be managed as a controlled experiment. We begin with the equipment in a maintainable condition and perform specific actions to prevent failure. That's just my definition. The maintenance culture is reactive, and if your maintenance culture is reactive, the plant culture is reactive, 100%. Organizations feel repeatable procedures not needed, or techs are experienced, so they know what they're doing. And when I was at one plant and they telling me this one guy's kicked back, and next thing I know, that afternoon when we're leaving, he's walking around. I said, "Hey, Jim, what's going on, man?" And he said, "Trying to find my car keys." He doesn't forget anything. Right. Okay. Techs feel, they know how to perform maintenance work correctly without specification. Hey, we're humans. We're full of error. It depends on when you come to work that day. Let's say last night you went out, maybe had something to drink or something to smoke, whatever, or you did nothing. It's just somehow your brain's not thinking the same way. When you walk in that morning without a procedure, it won't bring you back into focus. And that's what a procedure is, to bring you back into focus. Overnight deliveries sit for weeks or months. I've seen it too much. Everyone works as hard as they can with little, if any, movement toward proactive. Storerooms chaos. See people standing in line. See that storeroom over to the right? That's a big storeroom, man. They're chaos in that plant. People standing in line at 7 a.m. waiting on parts. That's reactive. Store them as excess inventory just in case. We got to up that minimum stock level. We got to make sure we have more parts in stock. We're using a lot of them right now. Maintenance rework is high. However, there's no one can determine the true root cause of rework. I wonder what it is. That could be an interesting topic. And no one knows there's a problem. Got no scoreboard. We don't know where we are. We're lost without a scoreboard. Tell us how we're doing. So I'm going to talk a little bit about, this is Jack Nicklaus. This came from Jack Nicklaus. It's called procedure-based maintenance. I've got it on my website. You can download it. It's a great document. But in this document, it talks about procedures. So Jack talks about in the field of maintenance, the traditional approach has been to rely on the intuitive knowledge and skill of the craft tradesperson who conduct it. There's a great deal of pride of workmanship and all too many organizations, a great deal of kind of a psychic income, in addition to a significant overtime pay for successful emergency repairs. In other words, we get the pat on the back. Hey man, good job, man. You got us up and running fast. Yeah, right. Okay. There's a mystique that accompanies all of this that many skilled craft people would like management to believe firmly. I mean, there's some kind of mystique. Yeah, I'm the fast guy. I can go out there and I can fix it fast, So I'm the magic guy. That is where, there are too many variables in maintenance, making compliance with written procedures impossible and impractical. And you always hear that's the way we've always done it. It's the best and the only way to conduct maintenance. We always do what we always did, and you always get what you always got. This idea spills over to preventive maintenance. Also, craftspersons believe their own intuitive knowledge is preferable to a written procedure than a thorough defined checklist. This document, you can download this on my website, and I can tell you, if you're going to take the CMRP, Jack Nicklaus was involved in the nuclear Navy in the early stages. So there's some questions on the CMRP exam that Jack talks about that I tell you, I've never seen a CMRP test that didn't have those questions on there. Okay, so what's the cost of not using repeatable procedures? Okay, so let's look at maintenance costs in a typical and a world-class, organization. So we got metrics down on the left side. We got what's typical, numbers, and then world-class. So first, we got maintenance costs as a percent of replacement asset value. This is the international standard. Typically, you find it's 3.5 to 9%. But look at world class. It's 2 to 3%. So let's just say you're at 4%. Okay. So how much more money are you spending in maintenance because we're not doing the right thing? And I can tell you, these repeatable procedures is a big hook on that one. It really sets out your difference by repeatable procedures. Where this came from was Alcoa Mount Holly, world-class maintenance model, and where I work. And I have to tell you, this whole thing about costs go with doing things the right way. Material cost is a replacement asset value. Look at the difference, 1 to 3.5% to 0.25. That's 4 times the 1. Okay, the 0.75. It's amazing. Attributes of a typical organization versus a world-class maintenance organization. All maintenance work, a typical maintenance organization, all maintenance work is not captured by a work order. All work must have a work order and must be charged to an asset, unless you've got something like, I don't know, very little, like maybe a safety meeting, okay, that I don't count those. Maintenance work is based on the text knowledge, it's the tribal knowledge, what the tribe knows, the tribe does. Maintenance procedures are not repeatable. It's a fact. Example, procedure says check chain drive. Yep, check chain drive's there. What am I checking? So I should have step-by-step instructions on that. Lubricate bearings. Okay, so how many grams of grease do I put in it? I have asked people that, and they said, I don't know, I put about 2 strokes in it. I said, 2 strokes? What's 1 stroke? How many grams of grease is 1 stroke? I don't know. Really? Manufacturers have this information. And then maintenance rework is high. So rework, you've heard me say it before, rework is corrective work done on previously maintained equipment that has prematurely failed due to maintenance operation of material problem. The causes of rework, maintenance operational of material quality issues. This is the SMRP metrics is where this one came from. So world-class organization attributes. All planned and scheduled maintenance work using repeatable procedures. So all plan and schedule work uses repeatable procedures. When repeat failures occur, maintenance procedures are analyzed. So if we have repeat failures, what's great about it is get a team of maintenance people together and say, we're having a lot of problems with this piece of equipment right here. Well, why don't we just go in and look at all the procedures, what we did to it, and all the information, the history of it, and maybe we can come up with a root cause fairly easy. It works, believe me. Maintenance rework's minimum and controlled. You'll never eliminate all rework because we got human error, but we can control it and we can minimize it. The maintenance cost is controlled. Okay, we don't have to spike up, spike down. And probably none of you ever heard it from at your sites when management says, "Hey, we can't spend any more money this month. We've run out. The budget's it. Don't call and order anything." Okay, yeah, and that's reactive. You got to do it, but to get out of it's the big deal. That's what we want to do: is move to that forward proactive stance. Human-induced failures. This is what it's all about. With these procedures. 80% of equipment failures are human-induced, meaning the failure was caused by the actions of people. An example of human-induced failures: repairs are not made with repeatable procedure, so everyone does a little or a lot differently. So everybody does it differently, creating an uncontrolled deviation to the reliability of equipment. So mechanic one, okay, this is an example. Lubricates an asset, follows a repeatable procedure, does the job the right way, results in a mean time between failure far exceeding expectations. The average time between failure goes like this to this. Okay. Mechanic two lubricates the same equipment without a procedure and just does it like he always has. Doing however we do it, that's the way we do it. Not knowing the proper contamination control method. MTBF is out of control, but no one knows it because it's not measured. Okay. So here we got a chart on bearings. Okay. So we got the problem, root cause. So here's one: bearing failure due to contamination of grease, dust, or silica. What's silica? It is dirt. Okay. Failure, root cause: failure to wipe grease fitting or the end of the grease gun nozzle clean. Here's another one: failed bearings and damaged gear teeth due to contamination causing interference between gears, thus overloading bearings. The root cause: gear oil added to the gearbox through a dirty funnel or dirty container or bucket. Electric motors, windings failed because of grease inside the motor. Relief plug was not removed when introducing grease to it. I went to a plant one time and they were having a lot of problem with motors. I was there to look at the motors, large horsepower motors they have a problem with. And it was kind of interesting because I go out to one, it's about a 500 horsepower motor. And I look underneath it, it's got a relief plug. It's got a plug underneath it. And I said, you guys removed the relief plug underneath that motor at the bottom of it? Oh, no. So you lubricate it? Oh, yeah, we lubricate it every month. That's why we don't know why we're having those failures. I said, that's a relief plug. What you're supposed to do is have the motor rotating as you pump grease into it. That's why you usually have an external line going out to it or some kind of pump for it, but you got to have a relief plug. In other words, you got to remove the plug underneath it or put a relief on it where it purges the old grease out. Gosh, amazing. So text in on this one human-induced failure you have seen or experienced. Just text it in.
Waiting for some responses. We have a couple of people typing.
Come on, everybody's seen one.
We have an answer from Bill that says poor installation or lack of alignment.
Yeah, absolutely.
There's more people typing still.
Like aligning a coupling with a straight edge rather than a laser alignment.
Kyle said covers left loose. Duncan says not knowing the tension of a belt and just doing it until it quote unquote felt right.
Yeah, that's a good one. I like that.
Poor operation for a starter motor of a gas turbine.
Oh my gosh. Yeah, that's a bad one. That's an expensive one.
I still see some more people typing. Charles says not filtering oil before adding it to hydraulic units.
Whoa. Really? Hey man, I'll give you an A plus. Very rarely do I hear that. That's great. That's great. All right.
John says poor winterization program. Craig says wrong grease applied. Poor motor brake adjustment as per manual.
Oh, you got a manual. That's amazing. You know, and what we need to do on those manuals is take that information and put it in the procedure. So we have it. We don't have to go looking for the manual when we do it. But that's good. That's good.
Pump malfunctioning due to the motor rotating backward.
That will cause a problem. It really will cause a problem. All right, let's move on. So indicators of human-induced failures. Have you ever seen any of the following issues? If you have, you're likely to have a serious problem with human-induced failures, okay? Lubricating electric motors without removing the relief plug. Here's a good indication down below. You know, somebody kept pumping the grease in, pumping it in. All they knew is put 4 shots in. It had a relief plug underneath it. It wasn't a relief. All it was a pipe fitting. It was supposed to remove it, pump the grease as it's rotated till the new grease comes out. Welding in equipment without grounding within 6 inches of the welded area. Oh my gosh. You know, I was at a plant not too long ago, about a month ago, maybe 2 months. And the plant manager, well, it was the vice president. The vice president asked me, he was there because they had a lot of problems with this plant. And he would say, man, we got bearings fail. We got electrical problems. We got electronic problems. I don't know what all's going on. I said, well, it looks like you're adding a lot of new equipment in, right? He said, yeah, we're adding new equipment everywhere. I said, so let's walk around outside the plant. This is a massive plant. We walk around outside. The contractors got their welding machines, especially the ones that run off of diesel or gasoline up near the building. And the ground is connected to the building frame. And instead of it should be within 6 inches of the welded area. If it's not, then that current is every electrical failure, electrical device, bearings, whatever, it's going to go through and cause major problems. Excessive equipment failures occur without a known root cause, resulting in lost capacity. Operative not, here's a big one. If you look at how much money we spend, we lose, you know, not operating the equipment to specifications. I've done a lot of analysis on this over the years, and I can tell you it's massive. It's not operating to specifications, a big deal. Zinc anodes not replaced on water-cooled heat exchangers, causing tube damage and water intrusion into the oil. Probably no one's ever seen one of those, right? Anybody seen the zinc anodes in a water-cooled heat exchanger? They look. Go ahead. Somebody's text one in. They're zinc anodes. What they do in a water-cooled heat exchanger, so they're round. Is on the end of it, they have these little zinc anodes, and what it does is take the galvanic corrosion out of it, so it doesn't pit the tubes inside them. They're supposed to be replaced once a year. Tightening fasteners without the use of a torque wrench or even knowing the torque value. You know, this one was over torqued. And it's kind of amazing to me. You know, it's like if we got a loose fastener, you know, what we want to do, why did it loosen? It loosened because it stretched. So instead of replacing the fastener, we're going to tighten it again. Right. That's why we got problems. Maintenance personnel making quick repairs and not returning and restore it later. Nothing wrong with making quick repairs. When I was a maintenance manager, you know, I pushed my maintenance supervisors to make sure that when they had a breakdown, okay, and we have to do it fast, but we can't do it right, but we can get the equipment running, then immediately we're going to after that job's over, we write a work order to come back and correct it. We'll plan it, schedule it, and do it later. No repeatable procedures. You know, it's crazy. You know, we got to have repeatable procedures. That's what we're talking about today. Baseline KPIs and metrics before creating new and uploading new procedures, updating new procedures. Create a team to assist in creation of a maintenance dashboard to measure effectiveness at a new metric. So if we're going to set up metrics, I want to have a team. And I've got here my recommendation, 2 maintenance technicians. I want the smartest maintenance technician and the one with the biggest attitude, those 2 in there. Maintenance supervisor, maintenance manager, production leader, and storeroom manager. Identify which metric will be influenced through creating more effective procedures. So what metric would it be? It could be OEE. Identify 4 to 5 metrics to create a KPI dashboard to ensure new procedures are effective. Anytime we do something different, we want to make sure that we see the effect of it, and we got to measure it. So here's the dashboard again. So we got PM compliance 94%, schedule compliance is 32%, breaks to the schedule 14, MTBF of critical assets 124 hours, maintenance rework 8, stockouts 12, OE 76%. I think we can do a root cause on this one pretty easy. Very simple. You got to know the score in the game. I say this all the time. No matter what game you like to see on TV or you play, whether it's rugby, soccer, football, baseball, whatever it is, you got to know the score in the game. So what is required of a PM procedure? So this is page 1. Okay. We're going to have however you got your equipment block ID set up or your equipment hierarchy set up, you need to start there. Okay. You need to be on the procedure. We got project, so that could be an overall job, like, whatever it's on this equipment hierarchy, it could be on a certain production line. Then to perform PM on septet process line. So this is the line, okay, that we're going to do the PM on. So one of the first ones is perform PM on a hydraulic system. Okay. The frequency, okay, monthly, so every month. Estimated craft hours, I got 2 technicians times 3 hours. Okay, so it's a 3-hour job, so estimated production downtime is 3. The lab time is going to be 3. Yeah, I got that. Okay. The originator, version control, we need to have that, and making sure that we have approval. Warnings and cautions, okay. Warnings, failure to follow instructions could lead to death or serious injury. That's a warning. Caution, failure to follow procedure could result in early equipment failure. Then we got our PPE. And now we got our parts, the quantity, and so on. We got the part number. Why do we have that? It's because when the planner is planning the job and he knows he's got this job coming up, that he's going to go ahead and pull them from stock and have them kitted with the work order attached to it. And then that way, on the day you have to go perform this work, all they got to do is, the supervisor opens the cage, you go in, and there's a work order like this that's sitting on your pallet or a box or whatever it's in, and you grab it and you go to work. Consumables, any consumables needed, special tools, anything a maintenance technician doesn't have with them. If they roll around a big toolbox, they may have all this in there, but it may not. Any mobile equipment, special equipment, required departmental coordination, big deal. We got to know what that is, because when we work with production on planning a job, scheduling it, we got to make sure they know what we're expecting from them. And then we got lockout, tagout procedure. So this is page 2 of it. Okay. So now we're getting into procedures, steps. Okay. So you notice we got the steps to the left. We got the description of what that step is. So red, remember, warnings. So lockout, tagout, hydraulic system. So evidently this must be a very high pressure system that could cause, some serious injury. Yellow, cautions. Steps to follow along with each action. So you got each step that you follow in here, including like replace hydraulic filters, torque fasteners on filter, 12 foot-pounds, replace zinc anode, water cool heat exchanger. And here's just yes or no. Inspect 5 hydraulic hose for wear or leak. Yes or no. Don't care how much wear it is. If it's not spraying oil, just click it. Yes, it has a leak. Okay. And then inspect the rod seal for the cylinder. No leak, sweeping oil seal. Inspect rod yoke for thread and thread seal on thread brakes. Yes or no. Inspect all work after production is up to rate. So you don't leave, you wait the production up to rate. Now, up to rate. So you notice at the bottom down here, some subject values. Okay, got all that. All right. So we got, I'm sorry. So we total all these hours, the craft hours, and it comes up telling us how long the work is, okay, and how many hours we got of maintenance technicians. Always on the procedures, I used to love to have condition is found. So they found when they came out 3 leaking hoses, condition as left, clean reservoir and area, tighten hydraulic hose fittings. And then the last one, okay, comments. So any comments or findings for the planner, supervisor for possible future work. So here it says 3 leaking hoses, need to replace all 3 hoses and fittings, rod seal, weeping oil. So that tells the planner we got future work we got to look at. Craft feedback on procedures. Needs to add clean outside of reservoir. I wanted the craft to do that because they know what needs to be done. Hey, it's not on the procedure. Why not? Well, we need to add it on there. That's why I like this type of procedure. And then we want the John Hancock, the craft signatures on there. Okay, 1, 2, 3, 4, how many's on it, and the date. All right. Copy this similar PM procedure template. I've got a Word document that's 3 pages. Okay, you can go in and copy it, download it off my website. You can add to it because it's not like a solid template. It's a editable. So you can edit this template to use it however you want to use it. So I've got it on my website. So requirements for writing a procedure to ensure repeatability, we need to have a clearly defined best practice. So if we're going to lubricate bearings, what's the best practice for those type bearings? Consistency and continuity. We need to have it written so we have consistency between our technicians and continuity when we're doing it. We got to reinforce that best practice in there by having specifications and so on. We can even use it to define training and certification. Like when you hire a new technician, maybe you don't call it certification, you just call it qualification. Just certain things I want to make sure they're qualified in, at some point, because they don't know your equipment. I mean, if they haven't, it could be a smart technician, but they still don't know your equipment. There's certain equipment, there's certain things about it they may need to know. Then it enables quality, safety, and environmental compliance. All right, so here's the steps to write or rewrite PM and corrective maintenance procedure. Similar cross-functional team. Provide PMs and corrective maintenance for the first asset, preferably the asset with the most problems. You don't have to get complicated about it. Review the work order history for the past 30, 60, 90 days. Provide a procedure template for rewriting with a corrective or PM procedure. And then rewrite it based on specific criteria, just like I showed you on this procedure, specific criteria, step by step. And then measure effectiveness of the procedures. We want to go back to that dashboard. How effective is this procedure? And then we talk about roles and responsibilities when we're actually writing, maintenance procedures. Now, you notice these tasks on the left, the decisions that are made, they're simple cross-functional team, provide PMs, all this, you just saw this. So what I've got them listed vertically, across the top is all the people that are involved in the positions. Now the way it works on this, R is responsible. This could be more than one person on the line. So a simple cross-functional team, we got 3 doers, okay? Maintenance supervisor, maintenance planner, maintenance tech. That, all they're doing is they're assembling it as a team. That's all that is. The maintenance manager is accountable to make sure that team is assembled correctly. Then go down to rewrite corrective maintenance PM based on specific criteria. Again, we got the maintenance manager accountable. The buck stops here. They're not the doer. They just, if things go wrong, we're going to go to that one person. Responsible, maintenance supervisor, maintenance planners consulted, okay? Only because we may need information from them. Maintenance tech's responsible. Maintenance supervisor, maintenance tech working together on these procedures. Production leadership, just informed. So knowledge of best practices is a requirement. It's not optional. Most people try to wing it thinking they know what best practice is, and a lot of people don't know it, and that's okay. So education, best practices, so best maintenance technician practices, like I got a class starting tomorrow morning on best maintenance technician practices, but we got these toolbox talks. You'll find these on my website too. So I've got a lot of toolbox talks on there. You can use PM best practices. So here's single point lesson, preventive maintenance fundamentals. And these are single point lessons. They're simple. They're not complicated. The way you use these single point lessons or toolbox training or whatever you want to call them is that you assemble a team and you give every one of the team members a copy of it, and then you go over it. You discuss it. So step by step, we go through and we just have a discussion. We don't have to get crazy about it. It's just a general conversation, and so they can learn from it. Write general procedures, replace electromotor. These are general procedures. So if I say I'm going to write procedures for anything from 25 to 100 horsepower, they're going to be very similar. Only thing that's going to be different may be the specifications. So if you do that, it's going to help you make it a lot easier by having procedures and have them where they can be modified quickly. And once you write it for an asset and you put that work order tag to the asset, then the planner next time can pull it out and put it with a job. Replace chain drive, hydraulic PM hydraulic system, and so on. PM conveyors, then measure the effectiveness, like we mentioned before. You got to know whatever you're doing, you should be able to measure how well it's working. All right, so recap. This is the BLUFF, bottom line up front, okay? Create a procedure template which can be used for PM corrective maintenance. You can download it on my website, assemble a team. By the way, on my website, you don't have to give your email address and none of that junk. I don't get into that. Okay, you just take what you want, leave everything, okay, that you don't need, okay? Assemble a team, SME, subject matter experts and proactive people, maintenance, engineering, management, whatever. Create an action plan. I like using the crawl, walk, run methodology. In other words, we start out, I call it the crawl because we're going to start out slow, but we're going to have to do something that's different to begin with. It's like, you've probably seen on old movies where the magician puts his hand in the hat, pulls out a rabbit, everybody goes, whoa. But that's what I'm trying to do with the crawl phase. I'm going to get their attention. This isn't the same old day. This isn't the same old thing. We're going to do something different. Okay, so this action plan is important. Define roles and responsibilities of the team using the RACI chart. So once we have an action plan, remember when I back I showed you got the steps in there, then we define roles and responsibilities using the RACI chart. Educate your team, best practices, single point lesson. Download the same website. Send 1 or 2 technicians to maintenance technician best practices workshops. Too late for this one coming up tomorrow, but I got other ones in the queue. And I'm the instructor. Send a maintenance planner to planning and scheduling workshop. Got one coming up in May. Okay. All these things are interconnected. All my workshops are interconnected together, and they should be. Send your senior maintenance tech to PM best practices and PM optimization workshop. If you send them to that, I'd recommend that they make them think about. I got a document on preventive maintenance optimization, PM optimization. Let them look at that and you review that document. I think it's like 4 or 5 pages. But when you go to PM optimization class, a best practices class, the PM optimization is a big one. They can come back and you can find an area of the plant to say, okay, Jimmy, when you come back, we're going after that asset over there because we've been having a lot of problems with it. We're going to do a PM optimization on it. So you bring back the information. Tell maintenance leadership about the best practices workshop. Maintenance leadership, this is a great one. Maintenance best practices, SMRP, body of knowledge. I added a body of knowledge because it's important. Whether you're going to take the CMRP or not, it's not that. It's about understanding best practices. And that the body of knowledge was created for best practices. Join the maintenance community by Upkeep. It's a big deal. The maintenance community is a great group on there. And yeah, there it is. Upkeep.org/community Slack. Okay. I think I'm bringing it up right now. Yeah, this is Upkeep. So you got events, resources, experts, partners, all kind of stuff on there. All right, move on. So check out my website for these free proactive maintenance information to include a procedure templates. What are your questions?
Thank you, Ricky. Wonderful presentation. There's a couple of questions in here. I think one of them got answered by another attendee here, so thank you so much. One of the questions here is, what's the trade-off between detailed procedures for infrequent, highly critical work versus checklists for frequent routine work? Is there one?
Not really. I mean, checklist, there's nothing wrong with a checklist as long as it has enough information. I mean, like the steps in a checklist just need to be a noun, adjective, and a verb. That's all. Doesn't have to be complicated. Check chain drive. Now we need to get more. We said check chain drive. We need to put something in there. So keep it simple. Doesn't have to be complicated. I've gone to plants where they got procedures that's like 3 or 4 lines. Nobody's going to read that. Make it short, noun, adjective, and a verb. So these things aren't complicated. But you're right. You can do that. All right. What's next?
That's the only question I see right now. Everyone, please submit any questions. We have a response to that says, I have some checklists, but they make reference to the 1-point lessons. That's great.
Procedure template I've got on my website's good. It'll help you a lot. You take all the stuff off of it, whatever you want, you can adjust it, change it, whatever. It's not a PDF, it's in a Word template document.
Thumbs up on that.
Hey, if you don't help people, who's going to help them, you know?
Yeah. Any other questions out there? I'll stall for another couple of minutes. That's all we have submitted so far through the presentation, but if there's any other questions, please submit those now, and we'll take a few more minutes here to answer them.
You could send my email, rsmith@worldclassmaintenance.org.
Mm-hmm.
You know, I didn't put that on there. I should have put it on there. If you got any issues, you know, you got a question, I answer them typically within a day or two. Okay.
There's another question that came in the chat here, Ricky, if you're ready. It says, is it hard to adopt CMMS work orders to keep this information? I'm assuming the procedure information.
I mean, some are easy to, most of them are difficult. So you have to have them in a library on the computer. That's why you got to have planning and scheduling. You know, that way the planner can pull them out and attach them on a job plan package when they go out. And if you have an unexpected breakdown, your maintenance supervisor should have access to it too on some kind of hard drive.
Mm-hmm. Jose says, I have a technician that always reacts negatively to new changes. What do you recommend?
Find another job. No, I'm just kidding. I'm just kidding. Okay. No, I used to have a negative attitude. Okay. I was one of those. Okay. So, you know, the best thing to do is get them educated. You know, this like the next class I got on best maintenance technician practices would be a great one to have them in there. Cause I usually get 3 or 4 in the class that really push back hard, and it's good. It's good. I like it. I do it respectfully, but when they leave, I can't say 100%, but 90% plus come out and they say they definitely changed the way they thought things should be done. Anybody else?
Just reading some of the responses here. I don't think we have any more questions, but just making sure.
Like I say, if you have one, there's my email address right there. Just email me.
Yeah.
I don't put you on a list either. You know.
All right.
All right.
Well, thank you so much, Ricky. Ricky's contact information one more time is on the screen here. He's available in Slack as well. If you have any further questions, feel free to send them his way.
All right. Thank you very much. Have a good evening.
Have a great rest of your day, evening. I'll see you guys next time.